Now, one of the challenges that we have with the current design is that all external user agents need to know the internal IP of every phone or every user within the network. For a couple of users, a couple of host devices, that might not be a huge problem, maybe 3 or less. But imagine you have a company that has, say, 200 phones, and you have a user that happens to be working externally one day, and they want to call somebody that's in the office. To do that, they're going to need to know a lot of information. And the reverse scenario is also true. If somebody in the office wants to call that remote worker, they need to know the IP address of that person. So to work around that, what we need to do is turn Kamailio into a SIP registrar. Now, what a SIP registrar is it's essentially a database that contains a user to a device mapping. And that mapping is known as a binding, and each binding contains what's known as an address of record or an AOR. And there's also a scenario where you might have a user that has multiple devices. For example, I might have a soft client on my iPhone. I might have a soft client on my desktop, and I might have a physical phone on my desk. All of them map to the exact same user account. Now, for simplicity, in this course, we're not going to walk through how we would handle or building out the logic for parallel forking in this case, where we would send calls to all these different registrations at the same time. We're going to keep it simple and have only one registration that we need to worry about. So let's get started. To build the registration functionality, there's a couple of steps we need to take. Like most other things in Kamailio, we need to import the functionality first from a different module. In this case, it's the registrar module. So let's get started with creating that. So you need to make sure you are in your modules directory, and you want to create a file named registrar.cfg. So if we load that up, we can see there are a couple of things here. First, we need to do the load module, registrar.so, and then we need to do a couple of params. We're going to turn on method filtering. We also want to set max contacts to 1. This is how we are going to limit it to only a single registration, like per user. We are going to define the max expires. So this is the maximum duration for the contact to be registered, is what that is. So 3600, this is in seconds, so 1 hour. And then there's another one which is GRUU enabled, and we're just going to set that to 0 to turn it off. What that is that's a SIP globally routable user agent URI, and that's designed to reliably route a SIP message to a specific device or end user. This kind of contrasts with the SIP AOR, which can refer to multiple UAs or a single user, thus kind of contributing to routing confusion. There are places where you do want to use the GRUU, but for this video, we're going to skip that. All right, so you've got your file created, and then like other cases, we need to add that into the modules.cfg file. And before we define where we want to put it, we also want to look at the dependencies. All right, so this module must be the following modules must be loaded before this. So we need to have user location and stateless replies first. So you should be able to see I've put this here. Yeah, so we've got user location. I don't have SL loaded, so I'm not worried about that, but putting it right beneath the user lock one. Okay. There we go. Yeah, so you can see that here. Next, so we also make a route file that can handle the registrations. So in this case, we're going to make one that is named handle registrations.cfg, and that'll be under routes. And handle register is what we're going to name it. And right now I've got a couple of things commented out. We will enable those a little bit later. But essentially this is going to have a couple of lines. So yeah, of course we started off by defining the routing block. And then we have a conditional. If the method is a registrar or register, then what we want to do is we want to save this into the location database and then exit. We're fine with exiting on this because a registration, once it's done, then basically that transaction is over. You don't have to worry about other dialogues or any of that. So you could just move on from that point. Now that we have that file and you've got that saved, then you need to put that into your request main so that that gets called. We're going to put it a little bit closer toward the top. So we're just going to do route, handle register, and put it right there. And of course, we need to add that in to routes.cfg, and we just need to do an include file there. We also do need to do some things with PJSUA. For now, we are only going to update the back-to-back UA external, and we just need to add basically one line into here. So back-to-back UA external, we go into pjsua.cfg. For now, we only really care about this one, which is just adding the registration statement. I've already got a few things defined here, which are the username, the password, and the realm. You'll see that in an upcoming video, but for now, just focus on this line here, where you're only defining where to send the registration traffic. So once you've got all of those things defined, then you can restart Kamailio and the back-to-back UAs. And let me switch over to the other windows. So there's a couple of things we can do. With the new config applied, you can run a camctl command to check for any registered users. Let me do that down here. All right. So, or you can actually just do it as a one-liner as well. You don't need to jump on. Let me do that. You could do it as docker exec it Kamailio edge camctl ul show. All right, so right now I don't have anyone registered. Yeah, no AORs, you can see that there. So assuming everything went well at the restart, then yeah, we can do a couple of things here. So I actually forcefully unregistered this. What you're looking at here is back-to-back UA external 01. I'm going to run RR, which does a re-register. And if you look here, yeah, you can see the register request. And what's important about this is really that contact header. So SIP back-to-back UA external at 192.168.254.100. Yeah, transport, the TLS, and all of those things. And so now, if we rerun this command, you can now see that in the AORs, we now have an AOR for back-to-back UA external, and you can see the address, which is the exact same thing that is pulled from the initial registration. You can see the expires here in this case. So in this case, it is set for 280 seconds. Now, even though in Kamailio we set the max registration for 1 hour, you can see in the register message, if there is an expires header, you can define it with a smaller value there. So if I rerun this again, you'll see that that keeps decreasing in this case, so 237. And what's actually going to happen is halfway through that time, so 150 seconds, then the user agent is actually going to resend another registration command. All right, so you can see a couple of things there. You can see the output of the Kamailio command, camctl ul show. You can see that we have some data here. You can see the registration request, the outbound message, and then of course the response. So we have a successful registration. So let's start doing some other things in the next video. We now have a user registered, but we lack an easy way to route the call to the registered user. So what we need to do is we need to add lookups to the invites. So let's edit the request main file and perform some lookups from here. All right, so in VS Code, let's find routes, and then we want to find request main. And down toward the bottom of this, right before route relay, what you should see is a section that is saying determine the outbound route, and we have a conditional. So if the method is invite, you can see I put a comment. We first want to check for registrations. And what this is doing is it's saying, okay, if we did not have a successful lookup against the location table, then we're going to log that it's not registered. And then we're going to send a reply of a 404 not found. And then we're going to exit out. So make sure you add that in there. And we're also going to make our lives a little bit easier with the back-to-back UA internal 01. Rather than typing out all of these, the full address that you need to call, we're just going to make a PJS UA file and add some buddies into there to simplify that part of it. So under your back-to-back UA internal 01, create that pjsua.cfg file. Basically, you're taking what you had from the command that was getting called via Docker Compose, and you're just turning it into these line-by-line statements here. The big difference, though, is, yeah, you can see I do have now a register line in here, and we want to add the buddies, specifically this back-to-back UA external one, just to make it easier for making our calls. And last but not least, we do also need to edit the Docker Compose file. So you need to find where the back-to-back UA internal 01 service is defined. We need to add a volume. So basically, we're just going to say in the back-to-back UA folder, back-to-back UA internal 01, we're going to map that to /config. And then we need to change the command to be pjsua --config file. Config is config/pjsua.cfg. All right, so once you have all of those things done, what you can then do is do a Docker Compose down and then a Docker Compose up. Now, once everything is all restarted, let me clear out some things on this screen here. All right, so what we want to do now is we want to make a call from the internal over toward the external side. So over here is the internal, this is the external, and we're just going to look at some Kamailio logs here. Let me do Docker logs Kamailio-edge. I think I can do it like this. Yeah. All right. So we're going to make that call. So we can do M. We're going to call buddy number 1, which is back-to-back UA external. We can see we're doing some processing here. Eventually, this is going to do a little bit of timeout. It's doing a little bit of loops first for whatever reason. Have to check that out a little bit later. But if we look up here, we should see that we had, destination is not found, which maps to what we had in the Kamailio CFG. And down here, you can also see this line, back-to-back UA external is not registered quitting. That was the log entry that we added in. All right, so we can see we tried to do the lookup. It didn't work, and basically the call just failed from this point. So what we can do now is if we switch over to the external one, and if you type RR and then hit enter, what that's going to do is that is going to do a re-register. So if you look at this side, you can see, all right, this is now re-registered. That's the outbound request. We got a 200 OK back. You can see a little bit of traffic that came in from there, but don't need to worry so much there. The main thing is that we had the 200 OK to the register. All right, so now that we have that part, we can try to make the call again. So to M1, and this should be routing to us in a second here. And we got a bad SDP in this case, so probably something with RTP engine. Yeah, if we look at this line here, we've got no available proxies that came up there, so of course it's not going to allow it to go through. Let's just do a Docker restart RTP engine. So it's called RTP engine edge, I believe. Let's give that a moment. All right, Docker PS. It should be running now. All right, let's try that again with RTP engine now actually running. And actually want to continue tailing these logs. Still getting that with RTP engine here. So I must have left this disabled from somewhere in a previous video. So if we look at, if we jump into here and do docker exec it, Kamailio edge, cam cmd, and then if we run RTP engine show all, we can see that RTP engine for whatever reason is disabled there. So we should be able to do RTP engine dot enable. I can't quite remember the full command for this one off the top of my head, but I think it is not enough params. Let me look that up really quick. All right, so we should be able to do RTP engine enable all one. In theory, that's going to do something. Status was fail in that case. Okay. I wonder if it is. Let me just do a docker compose down. It's like often with any changes made to docker compose, sometimes there's weird things that happen. So let's just shut it down and start it over again here and see if that makes a difference. All right, RTP engine, please work for us this time. All right, so it's back up, and yeah, that restart seems to have done the trick there. We can see that disabled is now 0, and we do actually have it showing up. So I think we're good there. We also need to reattach now to all of these user agents. And then let's make sure that we are re-registered on the external side. And let's get to where we can tail these logs again. Okay, now let's make the call. So make the call from external. Let's see, I do need to answer here. We're going to answer with a 200. And yeah, you can see that we now had that call go through. Yeah, just because we now have a user that is registered and it was able to be looked up to figure out where it actually needs to go to. So if we try to make another call to a user that is not registered, if we go to buddy number 2, then we should quite quickly, now that RTP engine works, we should get that 404 destination not found, and everything is working as it should now. Now, in the next video, we're going to add in some authentication to make things a little bit more secure. With the current setup, we're allowing anyone to register to the proxy without supplying any username or password. So while that might be interesting in a very open SIP registrar project, it doesn't really meet the requirements that we set at the beginning of this course. As such, let's add some authentication capabilities. So let's switch over then to our editor then. And yeah, we need to once again import a couple of different modules. So the two modules that we need to import are auth and authDB. We start with the auth one here. This one is super simple. So all we need to do is create the auth.cfg, and then we'll add just the statement of load module auth.so. AuthDB, there's a little bit more involved in that one, mostly that we just need to define the database URL. So in AuthDB, just make sure you load module authDB.so, and then mod params, authDB, DB URL, and then we'll use that DB URL variable that we've already defined. All right, so after we've gone through and we've defined these, then of course we need to go back down to our modules.cfg, and we also need to be a little bit careful about where we load these at. So if we look at the dependencies on these, The auth one depends on SL, and so we have to have that loaded first. And then authDB is just depending on auth plus a database module, so we're good already on that one. Next, we need to edit the handle register route block to basically allow this to do some extra checks for us. So if we go back to routes and then do handle register, I have this commented out on mine right now, but I can just take away these comments. And this is essentially all that we really need to do. I'll walk through that, but first let's talk about what these modules are actually doing. All right, so the first one, auth check. So the auth check function, it's combining the functionalities of www authenticate and the proxy authenticate functionality that Kamailio is going to use. So the www authenticate, that is used when you're doing SIP register methods, and proxy auth is going to get used for all other types of methods, like if you want to authenticate your invites and you publish messages and so forth. All right, so if you look at this function, we have a couple of different parameters that we need to pass. The first one being the realm, then the table, and then the flags. So the realm is typically the domain of the host. Next one being the table. So in this case, this is the table in the database that's going to be used for the names. Like if I connect into this really quick, I think Docker got shut down, so let me just go and start that again. And then if we jump into the database, just to show the tables that already exist, so we could do Docker exec it edge. We'll do camctldb connect. Maybe. Might help if I type exec properly. There we go. So if we do a show tables here, yeah, then we can see that I have a subscriber table, and then if we do a describe, yeah, you can see basically the table looks like this. So you've got a username, a domain, password, and then you've got a couple of hashes there. All right, and then we have the flags. So the flag value of 1 implies that the from and to must match the authenticated user. And if you look at a SIP register message, we'll see that in a minute. The next one is this auth challenge. So this is basically what is going to create that authentication challenge. So essentially it's going to send a 401 unauthorized when we get a registration message if the device isn't already registered. Also, we're calling the from, from domain URI is what this pseudo variable means. And then for the flags, we're just doing 0 right here. So essentially all we're doing is we just want to look up and do this quick auth check challenge. If the challenge fails, then we exit out. If everything is good, then we continue and go through the whole save process like we did in the previous video. While I have attached some other videos a little bit later in this course that go a bit deeper into the whole registration, we can get a very high level view here on just this mermaid file that I've created. I don't know if I can zoom in at all on this one. Yeah, maybe if we do that. Yeah, so basically this is just a very simple ladder diagram of what a registration looks like. So we've got the UAC, it sends in a register. The proxy is going to get that. In this case, the proxy and the registrar are the same. So the proxy is going to then pass that on to the registrar capabilities. The registrar is going to send that 401 unauthorized, and you can see that www authenticate, and it's going to say, hey, this is the realm that I want you to use, and that is because it came in with that. That gets passed back, and then the UIC then adds this authorization header and all of the digest that it needs to basically authenticate. If everything goes well, then yeah, then we get a 200 OK and everything's good. So very high level, that is the process on that part. So we've got a bit of logic. So what we can do now is we can do a restart on Kamailio. So just docker exec, or sorry, docker restart Kamailio -edge. So assuming that started, docker logs, make sure I didn't break anything there. Okay, I think we're good on that. Let me just do a docker ps real quick here. Yeah, all right, so we're good there. So we can go in and add, actually we need to do a couple of other things here. We need to add an entry in the subscriber table before we can really go any further. Already showed you the table up here. I don't know if my scroll back buffer can go up that high, but yeah, there is the table where all of the accounts need to be added. And right now we're going to focus on that external back-to-back user agent. So what we can do is we can just run this. Actually, let me just do it as, I'll show you the command here. So basically the command camctl add, what this is going to do is this is going to allow us to add a new subscriber. I already have this account created on mine. So if I try to run this exact same command again, it says it already exists, but you can see basically the syntax is camctl add, and then back-to-back UA underscore external at the host name, and then the password that I'm going to give it. Of course, this is a super insecure password in this case, but again, it's fine for this course. All right, so now we actually have this entry in the database, but we also need to do some modifications to the back-to-back UA config. So if we go up toward the back-to-back UA config for external 01, we go down to the pjsua.cfg, and you can see a couple of extra things that we need to add into here. So we already had that registrar in there. Next, we need to set the username, and we defined this username when we added it into the database, and we just put it as back-to-back UA underscore external. The password, we've defined that as password1, and we're stating that the realm in this case is, just the IP address of 192.168.254.100. This could also be an actual like FQDN. It doesn't really matter in that case. So we've got those. We want to do a restart, docker restart back-to-back UA external 01. Give that just a second here. All right, so it looks like that restarted. So in theory, we can go back over to our other window. Looks like I need to jump back on here again too. Alright, so we can do a docker attach back-to-back UA external 01. Alright, so this time we can do RR to send out that registration request, and let's see what we had happen here. Alright, so if we scroll up a bit, we can see that we had the original registration package that went out. And if you look at the from and the to here, you can see that these are the same. So remember that flag we had to set? That is referencing how this is structured here, which is what you will see with a registration. The from and the to are going to be the same. All right, next what happened? We got a 401 unauthorized, and you can see that this www authenticate header was added with the realm being 192.168.254.100, which that was what was specified already in our from and to. And then if we look at the next registration packet that came from the UAC, you can see we now have this authorization header that was added on. The digest username is back-to-back UA external. The realm is here. And then we have this nicely hashed value here, which is essentially the password. And after that happened, then the proxy and the registrar allowed us to register. So you now have registration capabilities, and it's going to require authentication as well. So kind of nice on that part of it. In the next video, we're going to go through and do a couple of other things related to registrations. Now, before we move on into any of the other videos, let's talk about a problem that we actually just introduced with the registration logic. So right now, if we try to make a call from back-to-back UA external side over toward the internal, because the internal ones aren't registered, any invite that we get is going to basically be answered with a 404 destination not found. So to fix that, there's a couple of pretty simple things that we need to do. First of all, we need to make sure that we add an entry into the subscriber table for one of the internal back-to-back user agents. I've already got it added per se on my side, but the command you want to run is docker exec it Kamailio edge camctl add back-to-back UA internal 01 at 172.16254.100, and we'll just use password 1 again. You can see from mine that it already exists, but okay, so we've now got that part added in. And then the other thing we need to do is on that PJSUA file for the internal back-to-back user agent, we want to add in a little section at the bottom, just like we had with the external one, where we want to define the registrar. We also want to define our username, which, back-to-back UA internal 01, as you saw me add down here. The password being password 1, super unsecure, and then make sure I put in the right IP, 172.16.254.100. So in theory, if we just switch over and do a docker restart back-to-back UA internal 01, and then we'll just attach on it. And then our registrar URI is not specified. Let's see, what am I missing on this one? Well, it looks like the config didn't quite take, as we don't have everything when we do a dump config on that user agent. So let's just exit out of it. And let's restart it again, internal 01. Let's also restart any of the other internal ones that we've got. All right, and then we're going to reattach. And then if we do a dump config, looks like we might still have a problem with it. Let's just do a docker compose. We'll just take it all the way down for now. And after that, we'll bring it back up again. All right, so Docker came back up. I went back into the back-to-back UA, and then I ran the RR command, and it looks like we are now actually getting registered. So that's good. We now have a registration on the internal side. So from the outside, we should be able to then make a call in toward that one. That one's number 2, I believe, right? Destination not found. Yeah, let me just make a full call over to this one. I think I need to update the buddy setting on this as well. But yeah, there we go. So if I put in the whole URI manually, we can see that I can now call into there without a problem. So just something that you do want to resolve. Yeah, on the external one, we probably, while we're at it and thinking about it, let's actually change. There we go. So we'll change one of these entries under the buddies on the or the contacts on the back-to-back UA external to the proper address to call into that one. And like everything else, just restart, and then we should have that working in a much easier way in the future.
SIP registrations. In the world of SIP, user agents may frequently change IP addresses. This can create an issue when one user wants to call another and they can't be found. To combat this, SIP allows users to register with a special type of user agent server known as a registrar. When a registrar receives a register request, it can take a number of steps. First, the registrar may perform a lookup to see, does this user even exist? If not, the registrar will most likely send a 404 not found in response. It's also possible that the registrar is configured to not accept requests from this specific user or UAC. In this case, it's likely that the registrar will send a 403 response. In the event that the user is permitted, the registrar will respond with a 200 OK. Of course, it could respond with a 401 unauthorized as well before allowing registration to take place, and really it should do that just for added security. Now, in the background of the registrar server, it is communicating with an abstract service known as a location service. Now, keep in mind, a registrar and a location service could be on the server, or it could be a diverse element. Once a user has successfully registered, a binding is created for this address of record, right? So we have this register message going through, hits the registrar service. We then send it's a successful registration. So the location service, it tracks it in there. It says host, domain.com 5060, registration time. This is the time the registration took place. Username is Bob, and the state is registered. And then the UAS is going to respond back with a 200 OK saying, okay, you're registered. Here's your expiration time. And the AOR, or the address of record of this entry, is going to be taken from the to header. And the information on how to reach the user is taken from the contact header if present. That's where we got like the host domain.com and all things in there. Keep in mind, a register request can add, remove, or query an existing binding. Although a register request and response contain the necessary components of a SIP dialog, it doesn't create a dialog. And record route header fields, well, they have no meaning when it comes to registrations. In fact, a registrar and a UAC must ignore them if they were added anywhere along the path of the request or to the response. So let's take a little bit of a deeper look at the components of the register message. All right, so we have the register, or the request URI, and the RURI names the domain of the location service for which the registration is meant. Look at that line. You do not have SIP : username at domain 1. No. You just have method space SIP : host and then SIP/2.0. Like I said, notice they're missing. They are not part of the register RURI. From header. The from header will contain the AOR of the person responsible for the registration. This value is the same as the to header unless it originated from a third-party registration. The to header. This contains the AOR of the registration that is to be created, queried, or modified. Call ID. All registrations from a UAC should use the same call ID value when register requests are sent to the same registrar. often we're going to have a 401 unauthorized challenge occur. All right, so in the event that that happens, the call ID from regattempt 1 and regattempt 2, they will remain the same. C sequence. Each time a register request with the same call ID is sent by UAC, it must increase the value of this by 1, which in the RFC, this term always makes me laugh. It's monotonically, and all I can think of is somebody standing there with a grumpy face using a monocle. So remember that. Each time a register request with the same call ID is sent by UAC, it must increase this value by 1. Contact. The register request may contact a contact header field, or may include a contact header field with 0 or more address bindings. A UAC must not send another register request, i.e. one with a new contact header value, until they have received a final response from the previous register attempt, or if the previous attempt timed out. Registration bindings are only valid for a certain amount of time. There are 2 methods that a UAC can use to suggest the expiry time of the binding. Method 1. The client will send a register request. It can add an expires header field. Like if you look at this one over here, we have an expires in 3600. So that's method 1. Method 2. The client can add an expires header param right here into the contact field. Those are the 2 ways that the client can set that. Or it could do nothing. It could say, I don't want to use either method. So in that situation, the client is telling the server to choose that value. So you will see the server response by setting, or the server respond by setting an expires param in the contact header field right here. And so in that case, the client should receive that, and it should follow that time listed. So it will re-register within 3600 seconds. But to remain registered, a UAC must send another register request before that expiry timer is up. As discussed earlier, the register refresh request will contain the same call ID, and it will increment the C sequence value monotonically. Now, to tear down a binding, there are times where a UAC may wish to gracefully unregister. One example is when a physical phone is rebooted or a soft phone is shut down. The graceful teardown to the registration, well, the UAC is going to send a register request with an expires equals 0 in the contact header field, or through an expires 0 header field. 2 different ways. Just the reverse of setting up how long you want your session to remain active for. So jumping back to the UAS, which is the registrar that receives these requests, it runs through a series of steps each time a register request is received. There are so many sub-processes that take place on SIP servers, but I guess that's the case with any other system, right? So step 1, the registrar looks at the RURI to determine if it has access to the binding for the requested domain. If not, the registrar does not need to act as a proxy server, and it can just reject that request. Step 2, the registrar will inspect and process all values in the require header field. 3, the registrar should authenticate the UAC. If no auth method has been configured, the registrar will take the from address value and assume that to be the actual originator of the request, but we know better than that. It should always authenticate for security. 4, the registrar should determine if the authenticated user is actually authorized to make changes to the binding. It could be a user trying to make changes for a different user, so we have to verify that that could happen. And if the user is not, the registrar must send a SIP 403 forbidden in response. 5, the registrar determines the AOR or address of record taken from the to header. If the AOR is not valid for the domain seen in the RURI, the registrar must send a SIP 404 not found in response. Step number 6, the registrar is going to look for a contact header field. If not, it's going to just skip to the final step in the process. If the contact header field does not exist, it will review the call ID and make sure this is the same call ID as the existing binding if present. And if a binding exists and the call ID is different, the old binding will be removed. Step 7, each contact address is now processed. This is where the registrar determines who is responsible for setting the expiration interval. Step 8, the registrar can now return a 200 OK as response, and that's it. That is the process a UAS that is acting as a registrar will take when it is processing that message. A few other things to remember. Remember, there are 2 or technically 3 ways for a UAC to determine how often it wants to re-register. It can send an expires header field. It can add the expires param into the contact header, or it can do nothing and allow the server to figure out that value on its own. SIP authentication. So SIP, it provides a stateless, challenge-based authentication. It's based on the same authentication methods that are used by HTTP, and anytime a UA or a proxy receives a request, it may challenge it to really find out the identity of the originator. A proxy must issue a SIP 407 to issue a challenge, while a UAS, a registrar, and a redirect server, they can do a 401. Once the originator is identified, the UA challenging should determine if the user is actually authorized to make the request. Now, under the old RFC 2543, servers could accept a request from a UAC that wanted to use basic auth. Under RFC 3261, servers must not accept credentials using basic auth. Under the current RFC, servers also must not challenge an auth request where basic is used. Now, all but 2 SIP methods can be challenged. A cancel is not challenged because they cannot be resubmitted, and an ACK is not challenged. Now, if an invite was challenged, the UAC must send an authorization field in the ACK that is used for the original invite. What I mean by that, if an invite went out and the invite was challenged, the invite then sends another invite to go through the challenge testing on there. It goes through the challenge response. The invite now has an auth header field listed in there. Now, if this UAC sends an ACK, it will copy that exact same header field in there and send it toward the the UAS. Fair game on everything else, though. All the other methods can be challenged. And since basic is out of the question, let's focus on digest auth. Now, digest auth works by challenging the original request. When a request is challenged, the UAS will reply with a nonce and domain presented within a www authenticate header. When the request originator responds to the challenge response will contain an MD5 checksum or hash or of various parameters such as the username, password, realm, etc. These are found in the authorization header. So here is the process of authentication on a register message. The UAC sends a register out. Notice no credentials are sent in this request. The UAS responds with a 401 and it adds a www authenticate header with the realm of fake server, a domain of sip.fakeserver.net, and a nonce. So notice that header. And this is where the hashing algorithm comes into place. When the UAC receives the challenge, it needs to compute the response properly. And there are 2 algorithms, one where QOP, or quality of protection, is requested, and one where it is not. And we do this it's a process of creating 3 different hashes. The final hash, the third one, is what we send as the response value when we complete the challenge. So hash number 1, it is a hash of the username, the realm, and the password. So hash 1, it looks like MD5 hex, user, fake server, password 123. Right, so we have these over on the side as well. So that is the algorithm for hash 1. It's username, realm, password, MD5 hex is what those are hashed with. Hash 2 is going to be a hash of the method and the URI. We know that this is a register method, and the URI is going to be gleaned from the domain in the 401. So hash 2 is an MD5 hex of register, and then the domain, and there we go. The third hash is a hash of hash 1, the nonce, and hash 2. So hash 3, it's an MD5 hex of the first hash hex, the nonce, and the second hash hex. So H3 will be sent as the response in the authentication header. So there we go. Our UAC has processed this, and it knows its own password already. The person that has the UAC, they have entered that in, or the SIP network admin, they have put that into a config file. So the UAC, it knows what the password is. It doesn't just glean that from the UAS, from that challenge. It doesn't do that. But let's look at that. We have the authorization header. We got user B, realm fake server, there's our nonce, there's our URI, and then we have the response, which is that hashed value that we created. In the event the quality of protection is required, the third hash is slightly different. It looks like this. We have hash 1, the nonce, the NC, the C nonce, the quality of protection value, and hash number 2. Notice the extra fields added into the middle. Section review on this. SIP authentication is based on HTTP auth. When a UAS register or redirect server authenticates or requests it, it's going to send a 401. But when a proxy requires authentication, it will send a 407. Basic auth is not used, and instead a SIP digest auth is going to take place. When a 401 or 407 is sent with www authenticate, the header is sent with the challenge information. The challenged UAC sends a response within the authentication header, and the response is an MD5 hash created by 2 other hashes, a nonce, and optionally a few other parameters.
It's very common for a device to offer multiple codecs on their invite, and in many cases, you want to limit which codecs can be presented to a back-to-back UA in your core or toward the users that are external. So basically, as a refresher, let's just do a quick overview of where all of the codecs are actually listed at. So the codecs are not listed up here in the top part of the headers. They are listed down here within the body, and specifically on the M line. And if you also have video, you will have an M line for video as well. But in this case, we only have audio. But you can see we have quite a few different codecs that are listed here. And almost all of these also have an A line or an attribute line, which gives a little bit more detail about what all of those are. But you can see there's quite a few different codecs that are on here. Now, one of the things that was specified in the beginning of this video course was that we need to strip off basically everything other than G711A law, G711U law, and then we also want to make sure that we keep RTP events as well. Those are really great for just DTMF passing. So in this section, that's what we're going to do. We're going to build some rules that are going to strip off all of these extra codecs and just leave what we want to allow through. Removing these codecs is, of course, going to require some help from a couple of modules. We need to use SDP ops and the text ops X module. Now, SDP ops should already be loaded. We do have that one already in here, and it looks like it is already somewhere in this list as well. Yep, that one's good. However, TextOps-X is not yet loaded. Now keep in mind, this is a different module than just the standard TextOps. So you can see I've already created the file here for TextOps-X. Do the same on your side. Create a textopsx.cfg and then just include that load module line there. Yeah, so we've done that, and then also just make sure that it is listed within here on the modules.cfg. I just put this one right underneath the standard text ops. So pretty straightforward on that part. The next thing we need to do is, after you've got the modules handled, we need to create a new route block. In this case, we're going to create a route block named remove codecs inbound.cfg. So there's a couple of things we can actually do with this. Is we have this this existing routing block, set RTP request. There's some similarities here, so you could use this really as your foundation if you want. You can copy this and just put that into the remove codecs inbound, or you can just type along and work on it from there. All right, so like any other route block, we need to first define that yes, this is a route, and then we'll set the name, which in this case it is remove codecs. And then we want to first do a flag check. So if the flag from public is set, then we want to go through and do a couple of extra things. We're going to add in a conditional so that if the method isn't an update or an invite, we're just going to return out and go back to the main, basically into the main route. And then we're going to do some extra checks here. So we're going to say if there is SDP content, which is just another way of saying, does this message have a body? Then we're going to call this function here, which is SDP keep codecs by name. And the only codecs that we're going to allow through are PCMA, PCMU, and telephone events. Now pay attention to how you list these here. You don't need to have these separated into different sections like this, where all of them are surrounded by their own quotes. It's all going to be one string with the codecs just separated with a comma. And I believe this is case sensitive, so keep that in mind when you're typing this in. Then we're going to do some extra things here. We're going to say if message apply changes doesn't work, then we're going to basically just log and say that, hey, we had a problem removing a codec. Otherwise, return 1. So message apply changes, all this one does is it goes through and basically saves the changes that you've done before it gets into any further in the processing. I've always found that when you're manipulating the SDPs, and often with headers as well, you just want to do a message apply changes just frequently rather than waiting until the end and hoping that it actually works. All right, so once you have this file made, this remove codecs inbound, then we can go into the routes.cfg. Just make sure you add that in there. And then we also need to go into our request main, and we need to specify this in here somewhere. So in this case, I am just calling this route here, basically right underneath the handle register. Yeah. Just add that in there, route remove codecs inbound. And what we can do now is you can then do a docker restart Kamailio-edge. And we should be able to make a call and see something happen here. So let me start this one again. Let me switch windows here. There we go. So docker restart, not restarty. Gonna restart external that one, and then we also want to restart internal. And then we can go ahead and just attach on these. so what we should be able to do then is we should be able to just see what happens as I make a call. So I am going to call, back-to-back UA internal 01. And let's just scroll up to the initial invite here. Let's see, that's the 200. All right, yeah, so this should be our invite here. Call IDs match, MR, yes. All right, so on the original invite from the external side, you can see I've got the massive M line here. I've got a bunch of different attributes that are listed. But if we scroll down over here, after it's been processed by the proxy, you can then see that the M line is drastically removed. So we only have 0, which is PCMU. We have 8, which is PCMA. And then we have 96, which is dynamic. And this is linked to telephone events. So exactly what we defined in that config file. So essentially, that is all you need to do to really do some codec stripping with Kamailio. And just to recap, if you haven't had to do codec stripping before or limit what you are sending, at some point in time, whether you're doing an interop with a SIP trunking provider or some third-party service, there will be a time where you do have to remove some codecs. Now, I will state that there is also a way that you can do this with RTP Engine, but that takes quite a bit more CPU and processing resources to actually pull that off, and you're a bit limited on what you can do by doing it via RTP Engine. If you just do it at the text level, you manipulate it here, it's much quicker, and you don't have to worry about the same level of overhead. That's about it for this section, and into the next one, we will talk about protecting against traffic.